Welcome back to Ratio Fitness. Today we're going to continue on with our ratio number 2, NAD. Different energy substrates compete for shared amounts of NAD. The presence of one substrate can suppress the metabolism of another substrate. For example, carbs and fats, but also the substrate alcohol. So, quick review on alcohol metabolism. Ethanol gets broken down into acetaldehyde via the enzyme and the coenzyme NAD, like we keep discussing, grabbing the electrons. The acetaldehyde gets turned into acetate, again, with the enzyme and the coenzyme NAD. So for each molecule of ethanol, we are using 2 NADs. Okay, look at that, 2 NADs. So alcohol metabolism significantly increases the NADH ratio, the collected electrons ratio. Because alcohol is a toxin, it cannot be stored, buffered, or used structurally like a protein, so it becomes a metabolic priority. This depletion of NAD, making lots of NADH, is depleting NAD, and that's making a high NADH ratio. And that's not ideal. We don't like that. So what suffers? What substrates suffer? Well, carbs, as we've seen before, they enter into the cell, turns into G6P, G3P, P13, BPG. We've seen this before. We use an NAD there. Fats enter the cell, go into the mitochondria, get turned into fatty acyl-CoA, goes through a 4-step process called beta oxidation, and in the 3rd step, oxidation, collecting the electrons, that's where we use an NAD, and it does this step 7 times to break down fat, smaller and smaller and smaller each round, so we use 7 NADs there. We also then send the fats in the form of acetyl-CoA into the TCA cycle, the carbs in the form of pyruvate, then acetyl-CoA into the TCA cycle, where 3 NADs in this process grab more electrons so that we can ship them to the electron transport chain. If the alcohol, I shouldn't say if, when the alcohol is taking all the NAD, this step suffers, this step suffers, and this step suffers because we just don't have enough NAD. And that's it for today. Thank you. Talk soon.